Hi guys, so today we're just going to discuss parts of a radical function where it's increasing and decreasing, and we will be able to identify the intervals that that's happening at. So let's start off by writing this function a little more clearly because it's in a square root. And we have x squared plus x minus 6. Now, the one thing we do know about the expression in a square root is that it must be greater than or equal to 0. I can't take the square root of a negative value. So to that respect, I'm going to start by just setting it greater than or equal to 0, which means that I do have some marker points if I'm going to graph this. I'm going to start off by factoring two numbers that multiply to be negative 6 and add up to be positive 1. That middle number will be negative positive 3, sorry, and negative 2. Okay, so I'm going to set it equal to 0. It's factored, and the other side is 0. So 0 product property comes into play again, and we have x equals negative 3 and x equals 2. So on a number line, those are my marker points because I'm going to test the intervals around these two x values. So just keep in mind negative 3 and 2, that's where your y value is 0. So these are your x-intercepts. So anytime you solve for x, those are your x-intercepts, meaning the x values, the points on the x-axis. So they're all interchangeable with one another. Same thing for y-intercepts. They're points on the y-axis. And when you solve for y by making x 0, it's also the same thing algebraically. So I digress. Moving on, we're going to test out some numbers. So I'm going to pick, let's go with negative 4. Let's keep it simple. All right, so if x was negative 4, let's replace it. You could replace it here or here. I mean, they're both the same thing, but just know that it should be greater than or equal to 0. So if I replace that, I'll get negative 4 squared, which is 16, plus x, which is negative 4 minus 6. So I just substituted into the original function. You can substitute it into the factored form as well. When you are done, you should get square root of 6, which is approximately 2.44. All right, so from here, we'll test out one of the numbers in the middle between negative 3 and 2. So that would give me x equals 0. Now, when x equals to 0, technically, I would find my y-intercept. So if I replace all these x's with 0, 0 squared plus 0 minus 6, well, that would give me square root of negative 6, which can't happen because we can't take the square root of a negative. And all that means is there is no y-intercept in case you ever are solving for a y-intercept by making x 0. Just means that there's no points on the y-axis. But for us in this problem means that we're not using anything between negative 3 to 2 because it doesn't work. And then finally, you're going to pick a number to the right of 2, which will keep it simple. We'll go with 3, and we'll replace it into, I'm going to go with the factored form this time. So let's go with 3 plus 3 times 3 minus 2, and that will give you 6 times 1, which is the square root of 6, which is approximately, again, 2.44. Okay, so I know that when x is, I'm going to color coordinate here. I know that when x is negative 4, the y value is about 2.44. So right there. We know nothing here is being used. And when x is 3, the point is also around 2.44. So remember that I can't really draw, so okay, yeah, I figured it's not gonna really. Okay, you get the point. All right, so remember we read graphs from left to right. If I'm reading this here, it's decreasing from left to right. So this is not where the interval is increasing. Now, if I go to the part where I can't connect the dots, from 2 and on, it would be increasing. It's going up from left to right. So that means at what interval is the radical function increasing? That would be from 2 all the way to all the x values, so on and so forth, which would be infinity. Parentheses because we don't actually include infinity. All right, guys, hope this helps.